how many handshakes are needed if everyone is going to shake everyone else's hand? You can have the kids work in small groups of various sizes and come up with answers based on literal counting of handshakes. If they approach it that way, it provides you with an opportunity to see what kind of generalizations can be built, particularly if you have different size groups and different numbers of handshakes.
1, 2, 3, 4, 5.
Oh.
5. It's gonna keep on going
Then
down.
it's gonna go
4, 3, 2, 1.
Are you sure?
4, 3, 7, 6, 5.
Let's see.
I'm out. 1, 2, 3, 4, 2. That next is gonna be 1, then there's gonna be everybody's gonna be out. Then but 0.
Why 0?
Because he already shook everybody's hand.
Put it down. So he doesn't get to shake any hands. Well, you've already made your number sentence. What can you tell me about your number sentence?
It's going 7, 6, 5, 4, 3, 2, 1. It's going backwards.
Wait a minute.
Oh, it's going backwards. 0, 1, 2, 3, 4, 5, 6, 7.
So if you were to write a number sentence and there were 12 people shaking hands, can you show me what your number sentence would look like?
You're going to have to start with 7.
With what number?
11.
11. Why 11?
Because you can't shake your own
Write that number sentence.
Mr. Sus, can we do 1 plus 2 plus 3 plus 4 plus 5?
Why not? Can you? Can you change numbers around when you add?
Yes.
Can you mix up numbers to make them easier to add?
Yeah.
Can we use that 0?
Yeah.
Yeah. So what did you do? 11 plus 10 plus 9.
Went backwards.
You went backwards. If you switched it around, could you do that?
Same thing.
Okay. I want you to turn this over.
Yeah.
And we are going to do, if there were 20 people in this room, I want you to show me that sentence. Okay? If you were to shake 20 hands, what that number sentence would look like, and I want you to see if you can find a good way to add those numbers up.
Bigger because then I can.
Fine, whatever you have to do. I'm going to go check on these guys.
16, 17, 18.
Is there a way that we can change the order of these numbers and make them easier to add up?
Oh, yeah.
Kevin?
You can take the 0 and put you can change it around and put in the 19 where was the 0. Maybe that would be easier.
Can I do this? If I do this, 19 and the 0.
Equals 19.
That equals 19. What else can I do? 18 and 12. 18 and 12.
No,
That
Mrs.
would work.
You can do 18 and 1.
18 and 1?
Yeah, go.
Wait a minute.
18 and 1. 18 and 1 is 19.
About 17 and 2.
What about 17?
Mrs. Sus,
Wait. Let me just try this. So I've used those two numbers. Okay. And I've used these two numbers.
Mrs. Sus, you can count.
Wait a minute. Okay. We're picking up, these are pairs, aren't they? You're pairing. How many pairs of numbers do you think we're going to be able to make out of these 20 numbers? How many pairs of numbers, Andrew, do you think we're going to make?
10.
Why?
Because you need to get one on each side.
I'm getting one from each side, absolutely. And how many, what's half of 20 if I'm pairing them up?
10.
10. Well, let's see if we do make 10
And Mrs.
sets of
Sus,
numbers.
each one is equal to 19.
Do you think that's going to happen all the way down?
Yeah, because you started with 19, that's why.
And I added what number to it?
14 plus 5.
14 plus 5. What do you think? Division?
No, 19, 18, 17, 16.
Okay. And how about these numbers? Okay. All right, let's go. 12 and 7. So that's this one here. Okay. And then it's going to be what? 11 and 8. Okay, that's that one. And then 10 and 9. I have to be, no, anywhere else. I have nowhere else. I have all my signs. Why are they all 19?
Because the 19 and the 18, the column over here is high, is going down, and then that's going up, and every time it goes up, it makes 19.
So every time this one goes down by 1, this one goes up by 1?
Yeah.
Wow.
Expressing the pattern is the algebraic approach to the situation as opposed to giving a single number numerical answer, which is the arithmetic approach to the problem.